which is good. Less people quarantine means more healthy people. So we were kind of, okay, hopefully good with the front. But before I move on and we do a little bit more with compositions, is there anything that we've seen so far that people have questions on? Okay, so we're flipping to the back. And we have a bunch of composition stuff. So let's just remind ourselves what a heck of composition is. I think we just did one example yesterday. Once again, I'm like randomly skipping around, so just bear with me, just find that number and we're working off of that. I believe yesterday, can someone just confirm we did 22, correct?
Yeah.
Okay. I'm gonna go to 24.
We did 24.
Oh my God, look at me, we were on fire yesterday. Okay, I'm gonna go to 25. Me, we were ahead. Okay, since we did 2 yesterday, let's try this one. Okay, so this setup, we would read this as F of G of H of 2. This is called a composition. We're composing, we're kind of putting functions together. And just as a reminder from yesterday, when we are doing compositions, we work from the inside out. So I need my paper here just to look at my actual functions, but I kind of start inside. I'm gonna ignore that outside stuff for now, and that's when we'll start. So I'm gonna start with just H of 2. So one thing at a time. You can't do everything at once, unfortunately. You gotta kind of split it up. So I go to my H function, I'm gonna plug in 2. That would be what, 2 squared plus 1, which will give me an output of 5. Okay, that wasn't terrible. So now what we're doing is we're taking this output and that's gonna become our input as we work our way out. So the next function was G. So now I'm gonna use this 5 as my input. So in the G function, it's just 3 times x, so that would be just 3 times 5. That gives me 15. And once again, I'm just kind of following down. As I work my way out, the next function is f. I'm taking this output and making it my new input. So it's just the one from the previous step. And now I'm gonna plug in f of 15, which will give me 2 times 15 minus 1 for an output of 29. And that would be your final, because there's nothing else to plug it into. So from yesterday, compositions, I like them kind of set up like that because I can see, okay, starting at the inside, working my way out. So you're just doing each individual step and then using that as your new input. Okay, so we had done a few with kind of just plugging numbers in. I like numbers, they're delightful. But obviously with algebra, we're gonna be plugging in some variables as well. So I'm skipping around again. I'm gonna go to number, sorry, I'm just deciding which one I want. Number 32. So remember, this has an open circle, that means composition. So we saw in the front of it's just kind of like a dot, or it's filled in, that's multiplication. Open is composition, so that's the difference. When I see a problem like this, which we would read as G of F of X, I like to rewrite it, it just makes more sense in my brain, when I rewrite it as G of F of X. So I like that way, just so I can see, okay, inside, working my way out. But what I notice is there's no number to plug in, it's just the variable X. So we're just gonna have to work with that. So let's start with the inside. It just says F of X. So I'm just gonna write F of X equals. And all I can really do is look it up, what it is. So for that section, just be careful because we're kind of, where am I, 32? We're kind of bouncing around. For that one, F of X is gonna be negative 3x plus 7. So not even a lot of work involved, I'm just really looking it up, that's all I can do. And now if I'm saying, okay, that's my output, so now this is gonna be plugged into the G function. So in the G function, I'm gonna use -3x plus 7 as my input. So I like to kind of stay organized and do that idea, write it out, and then we're gonna plug it in. So now we just have to kind of pay attention and be a little bit organized here. The G function says 2 x, so we're plugging this in as our input. Please make sure you always put it in parentheses if it's an expression. That's gonna get squared, and then from that we're subtracting 8. So now that we have the setup, it's all about just being able to simplify as much as possible. So we're just using our algebra skills there. Remember, if you see a binomial, so 2 terms squared, you are going to take that binomial and multiply it by itself. Please do not square everything. So we call that expanding it. Then we have to do some distributing. So I'm just going to stay in these parentheses for now. If I distribute, I'll get what? 9x squared. This would give me minus 21. That will give me minus 21, so that would be minus 42x. And then plus 49. Remember that 2 is still on the outside. So now I need to distribute in, so a few steps here to simplify. That gives me what? 18x squared minus 84x plus 98 minus 8. And then last but not least, let's combine alike terms. So that one took a little bit of work with the simplifying process there. So just make sure you can follow those steps. I'm going to have you try one in a minute where you're doing a little bit of simplifying. Now remember, you're going to kind of work on whatever ones we haven't done in class on your own Thursday. You're going to check your answers Thursday evening. Friday, you're going to do your graded problem set. You're at home. You can look at your notes. I'm not going to pretend that you're not going to like peek at your notes. That's fine. So one, make sure your notes are correct. That would be the worst if you were working off incorrect notes. I do expect that, we're kind of being trustworthy just to make your life easier. So you can use notes. I do expect that you do not work together. So please make sure it is your work that you are showing. You're not just getting the answers or copying someone, because that's just not going to help you in the long run. So do your best. We're going to kind of do a few more. We'll see how we're feeling. What did I do? Sorry, I'm trying to figure out what I did on my last one. We're going to do 34, then we're going to kind of backtrack and then we'll look at things. Perfect. What do we have, about 15 minutes left? Perfection. All right, so I have 2 more compositions I want to at least start you with. I'm going to do number 34 with you, and then I'm going to have you guys try one. Now 34 is annoying, and I totally confused myself last period, and I need to fix this. But see that box above it? It says for 31 to 34, use these functions, but then for 34, it gives you its own functions. So I royally confused myself. So you might want to, in the directions, just say for 31 and 32, you're using those. 33 and 34 give you the function in the problem. So sorry about that. But if I'm looking at 34, it says G of F of 2x plus 1. Okay, so I'm saying, all right, this is a composition just by looking at that setup. So I'm going to organize myself first, and I'm going to work from the inside out. And I'm going to start with F of 2x plus 1. So half of this is just knowing where to start. So we're using, once again, don't refer back up to that little box there, as I was doing last period, really confusing myself. I'm just looking at the directions of 34. It says f of x equals negative 9x minus 9. So I'm gonna plug into that function, but x is gonna be replaced with 2x plus 1. Most of these have a little bit of simplifying, so you're just gonna do your best here. Negative 18x minus 9 would be negative 18x minus 18. And once I say, well, I can't do much else, then you just go to the next step. And the next step is, we work our way out. In the g function, I'm going to use this as my input. So in the g, I'm just using the directions right in that actual problem. The g of x function is the square root of x minus 9. So I'm going to do the square root of x is negative 18x minus 18, and then add that minus 9 on the end there. So all I can really do for this one is kind of combine like terms. Don't get freaked out because it's under a radical, perfectly fine. I would get negative 18x minus 27. And that's how you would just leave your answer. Don't feel like you have to go and do other funky stuff with the radical, just leave it. We talk about that later. We have a whole radical chapter, I believe. So I just want to do that one so you didn't get to the end and saw a radical and freaked out. But we can see it's really the same steps. We're just kind of changing what we're plugging in there. So I'm going to have you guys try one. I'm going to kind of backtrack a little though because I got a little excited. Why don't you guys try number 21 on your own? So on your own means, can you do it by yourself? If you need help, please ask. But I'll give you about 2 or 3 minutes. But you can always raise your hand if you need individual help. Oh, goodness gracious. Oh. I'll give you about another 30 seconds. We'll come back together. Oh, my goodness. All right, so let's look at 21. Your main goal right now, it's like a little self-assessment. Can I do this? So if the answer is no, make sure you're asking for help at some point. Because we have this graded problem set coming up, there will be some sort of other assessment at some point. The schedule is so messed up with Columbus Day now. I'll let you know when it's coming. But eventually you will have some sort of assessment on this stuff. So just make sure any issues you clear up sooner rather than later. So let's look at 21, we said, right? So for 21, we have f of x and g of x. It says we want to find g of f of x. Now this order does matter, so don't just flip them. So we have to write that as g of f of x, and we're going to work from the inside out. So f of x is first. There's not really much I can do there. I'm just kind of putting what f of x is. And for this one, that's x minus 1. And then what I'm going to do is I work my way out in the g function. This is going to become my input. Okay. So for g, I'm going to write it as x minus 1 squared plus 2 times x minus 1 minus 8. And now you had some simplifying to do, so hopefully you kind of follow that, keep going. Remember that means you multiply that x minus 1 times itself. That will give you x squared minus 2x plus 1. I can distribute into here, and then we have that minus 8. And your final answer, once your terms are combined, those would just cancel. 1 is negative 1 is negative 9. Your final answer, once there's nothing left to do, should be x squared minus 9. So can you please do a quick self-check there? Is there any part of that question that people would like to go over? I'll remind you, just as a general, when your teacher says, are there questions, and you don't ask them, I'm assuming you're good. So is everyone good? Okay, so if you're not good, that's your responsibility to seek out help. I will help you, but I just kind of go off what you guys told me. So just as a heads up there. There is one more thing I wanted to show you. And this is right in your packet. I was kind of copying and pasting. So my header might look a little different, but that's okay. So we were just combining some stuff from last year. So it's not really, I guess I kind of start to renumber. So after number 34, it says graphical representations of compositions of functions. So we'll look at that first graph just so you know what the heck you're supposed to do with that. And then there's another graph on the back as well. So let me get mine up just so I want you to see it before you leave, because I believe there is something on your little problem set there. Okay, sorry, it's not the best, but we'll go with it. And you have it right in front of you as well. So just looking, once again, it's under the graphical representations. My header looks a little different, this is what I was using last year. And it's asking us some stuff about this function, or this composition of functions, I should say. Because what we see is we have 2 functions. They're labeled. This is a little bit easier to see because you can actually see the colors, but obviously when I print it, you really can't. So right next to this one, we see this is the f of x function. Okay, so if we refer to f of x, that's what we'll refer to. And then we can see that this is the g of x function, a nice absolute value. So our main goal is to just figure out what the heck's going on. I will tell you, and I like even told my last class this, and I still got messed up. Be careful on the scale of this and anything in general. Sometimes with some of these graphing programs, you do it and it looks nice, and then you kind of copy it and then you realize the scale's kind of annoying. So if you notice, this is 0, this is 2, so technically this is 1, and then there's halves in there. So just be careful as you're reading it. Just my heads up to you. I still messed up last period, even though I told my class that. So this is going to be highly irritating because I just did this one and I realized something was annoying about it, and I'll show you what is annoying. This says, for number one, find each of the following, f of -1 and g of 3. Or I'm adding g of 3. So I'm gonna look up f of -1 in my graph, and this is why it is annoying, because I'm gonna go to -1, which is right here, by the way. And this is fun, because I'm trying to find it and then I can't actually see it. So that wasn't very well thought out, but we'll go with it. I'm just gonna tell you the output. If we kept going up here, the output was 7, I think. Hold on, let me just check. What's this? Rise 2, run 1. This is at 5, so the 7. So I'm sorry about the first one. The output's 7. I'm gonna assume in the future you won't just know that, so that was a little mistake ski on our part. But let's actually look at the graph. When I say g of 3, g function, I'm gonna go to an input of 3, which is actually just right here. So it's right there. G of 3 gives me an output of 0. Right? It's just a 0.3, 0. That's all I'm looking at. So it's telling me the x, I'm finding the y that corresponds to it. And then once you have your two outputs, you just add them together. So I'm sorry, because this graph is not the greatest. I will make sure to make nicer ones in the future. So when I say f of 0, I go to 0. I make sure you're just following it to the right function. So f of 0 is right here. And just think of the point 0, comma, that's going through 0, comma 3. So the output's 3. G of 6, I'm going to go over to 6, which is right here. I'm going to follow it up to the g function. I kind of label as I go. Whatever works for you works for me. That's going to be, well, this is 1 and that's 2, so that's 1.5. Once again, just that scale there is kind of annoying, so I'm sorry in advance. Some of these programs are just, when you try to zoom in, it gets a little crazy. But the main goal is just you're just looking at points. So just make sure you're using the correct function. It's giving you the input, you're finding the output. I'm sorry for number 3 again, this one gets all sorts of messed up. When you try to find, you would try to find just f of -2. But when I try to find that, it's nowhere to be found. So I'm sorry, just skip that one, that's fine. So I'll tell you right now, you can just skip it. You won't get points there or anything to get on. But if we could find f of -2, you would just find that, and then you would multiply it by 2, and then you would subtract. So that was our bet on the graphs there. I did want to talk about domain and range though. So we've been kind of randomly bringing it up. Domain is our x values, our inputs. Range is our output values. So when I'm talking about the domain of g of x, that looks like our nice absolute value function that's a v. We are going to assume, and we should never assume anything, but I'm going to do it just because of this program. We'll assume that those are infinite. So I'm going to put arrows on them. So if I ask what is the domain, you're really just looking to see is there any part or is there any x where the function's not hitting. But if we think about our x values, all of them have a point on this graph, no matter where I am, blah, 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 blah. And it's going infinitely in either direction. So we would say our domain is just all real numbers. The range, on the other hand, is not that way. Because if you think about the range of this, well, yes, it does keep going up in either direction. So that's exciting.
Good afternoon. Just a reminder to all students, if ever you're going to be absent from school, be sure that your parents call the main office, the attendance line, to let us know why you're absent. And also, please email your teachers to let them know as well. And I think that's about it. A reminder, no hats, no hoodies in the building. Now seniors dismissed.
So just as this is the last thing. When we're thinking about outputs, these do go up forever, but if I come down here, there's nowhere that g of x is gonna hit, right? So we call that the vertex because it's the bottom of the function, everything's above it. So we would say the range is, it's always gonna be Y. You just think about this, everything's above it, so we're gonna say is greater than or equal to. And then you just think about this Y value, and that has a value of 0. So all I ask over the next few days, do your best. You're finishing that up for Thursday. The problem's set for Friday. I'm after school today if you need help. I'm after school Thursday virtually if you need help. I'm always in here and virtual. So feel free to ask questions. And I'm happy to help you. Y'all will kind of start backing up because we start our morning announcements here. Oh my goodness, I'm tired.